This is number 3, taken from the A-level PastPaper C2 January 2014, and it's about differentiation. We have a curve, and this is its equation, where x is greater than 0. We need to find the derivative dy over dx, which is equal to y prime. So in order to find the derivative, we need to change first the number, the square root, into an exponent, which is half, and the square root, which is in the denominator, it becomes x to the minus half. Then you multiply half with the coefficient of x, and you subtract 1 from half. In this part here, you multiply 18 times minus half, and you subtract 1 from minus half, and the answer is going to be minus 3 over 2. Then when you clean up the fraction, or when you collect, simplify 2 and 2, you will get x to the minus half. Simplifying by 2 is 1 by 2 is 9, and the answer is y prime equals x to the minus half minus 9 times x to the minus 3 over 2. When you're going to derive this for the second time, it means you're finding d squared y over dx. Therefore, you derive again. So you take the derivative and derive it again. So you multiply this with the coefficient, and then you subtract 1 from minus 3 over 2. So you're going to have minus half multiplied by 1 is minus half, and subtract 1 from minus half, it's going to become minus 3 over 2. Same thing for the other number, which is multiply this by 9 and then subtract minus 1 from minus 3 over 2, you get minus 5 over 2. Simplifying, you get y double prime for this value. Use calculus to find the coordinates of the stationary point. So when we're going to find the coordinates of the stationary, so stationary means it's the point where it's either the maximum or the minimum, where you have the gradient equals 0, therefore the derivative is equal to 0, and then you solve for x. So you replace the derivative, or the value of the derivative, in terms of x equals to 0. Then you can either take common denominator, or you can find it in this manner by taking the 9 to the other side over x square root x, and then you can cross multiply. Then you have x square root x equals to 9 square root x. So now you take it to the other side, therefore x square root x minus 9 square root x equals 0. Taking square root x as a common factor, x minus 9 is left, equal to 0. So either x is 0 or x equals 9, and since in the given you have x greater than 0, therefore this is rejected. So the only value for x is x equals 9. Or you can use this method that I also wrote, common denominator. When you have a fraction which is equal to 0, only the numerator can be 0, the denominator cannot be 0. Therefore, you discuss x minus 9 equals 0, therefore x is equal to 9, which is greater than 0, and you accept it. In part C, before part C, we have to find the y of C, the y of the stationary point. Now, since we found the x of the stationary point, you can go to the function there, and you replace the x that you found in the function in order for you to find the y of the stationary point. So this is what we did here, and the answer is 11. So C has coordinates 9, 11. In part C, determine whether the stationary point is maximum or minimum, and you should give a reason. So in order to determine if the stationary point is maximum or minimum, we need to use the second derivative. Using the second derivative and replacing the x in here, you're going to get the value which is greater than 0. Now when the double derivative or the second derivative is greater than 0, then you have a minimum point. Now if the number that you got was less than 0, then you are going to have a maximum point. So in this case here, when you replace the value of x, the value of the coordinate of C, which is the x, when you replaced it, which is equal to 9, you replaced it here in the second derivative, and you found that it's greater than 0, the value of the second derivative greater than 0, then you should conclude that this is a minimum point. So C is a minimum point.